Hey guys, so here are the notes for the radical review. You guys have seen this already before, but we are going to be using this quite a bit throughout this unit. So I just want to review so you guys have a better knowledge and memory of how to do this stuff. Okay, let's go over our perfect squares. That's going to be very important to know, okay? So notice here we got two blocks. Basically, they give us our perfect squares. So we have 1, 4, 9, 16, 25, 36, so on. So those are the perfect squares. When you take the square root of the perfect square, we get our answer. So for example, we take the square root of 1, it gives us 1. And we take the square root of 4, it gives us 2. Square root of 9 is 3. Square root of 16 is 4. And then so on, okay? So notice here, we have a list of our perfect squares from 1 to 400, okay? Now you have options. Either you can memorize them. Really, you should have the perfect squares maybe up to 144 memorized, okay? Or you can kind of already put them together or multiply to get these perfect squares. This is what I mean. Remember, how do we get these perfect squares? Well, let's think about it. 1 times 1 gives us 1, right? 2 times 2 gives us 4. 3 times 3 gives us 9. And that's what we have, so on. So if you think, okay, well, I need to figure out my perfect square, all you have to do, and you can do this in your calculator, is just take a number, multiply it by itself, and that gives it a perfect square, okay? So you kind of have options. You can either use your calculator to determine what is the perfect square, or you can just memorize the list. Okay, now we're going to use this information to simplify radicals. Let's look at example 1. We have the square root of 50. Now the first thing you need to ask yourself, is 50 a perfect square? This is where you will have to go back to your list. Will we look? No, it's not. So now we have to think, well, what is the largest perfect square that is closest to 50, okay? So really we want to start, okay, we know it can't be 64, right, because 64 is too large. Well, then we have to think, can 49 go into 50 evenly? No. What about 36? No. 25? Yes. So 25 is our largest perfect square that goes into it. So that's square root of 25 times, well, what's 25 times something to give us 50? That's going to be 2. So now we take the square root of the perfect square, which is 25. Square root of 25, just plug into your calculator. If you don't remember, it's 5. But we leave the square root of 2 as is because we cannot simplify it anymore. So here's our answer. Okay, let's look at 92. So once again, look at your list. Is 92 a perfect square? No. But let's kind of figure out what's the largest one that goes into it. Now, we know 100 can't do it, so let's think of 81. No. So go down your list to see which perfect square goes into 92 evenly. Well, if you went down your list, 4 should have been the number that goes into it evenly, and it goes into it 23 times. Now notice how I am taking this out, right? I have 2 square roots, square root of 4 times square root of 23. Now I take the square root of the perfect square, so square root of 4 is 2, and I keep the 23 inside the radical, or the square root sign, because I cannot simplify it anymore. Okay, this is what I would like you to do. Go ahead and do number 3 and 4 on your own, so pause this video. Okay, let's see what you got for 108. 108 is not a perfect square, but the largest that goes into it is 36. And 36 times 3 gives us that. Square root of 36 is 6, and then we have square root of 3. Let's look at number 4. 27 is not a perfect square, but 9 is the largest, and 9 times 3 gives us that. 9 is the perfect square, so that comes outside of the radical, and I keep the 3 that's already in there the same. Okay, let's look at 62. Well, if we look at our list, this is not a perfect square, but let's see if there are any. Well, we know 64 is too large, so let's try 49. Plug that into your calculator. Okay, that doesn't work. Try 36. Nope, that doesn't work. 25. Nope. 16. Nope. 9. Nope. 4. So, in this case, there are no perfect squares that go into 62 evenly, so this means we cannot simplify. Now, if you're wondering, well, what do you mean, see if it goes into it evenly? Take 62 and divide it by 49. Put that into your calculator. Do the same thing, 62 divided by 36. Do we get a nice number? No. Okay. Okay, so what I would like you guys to go ahead and do is try 6, 7, 8, and 9 on your own. Pause this video and go ahead and do so. Okay, let's see what you got. 80 is not a perfect square, but the largest perfect square is going to be 16. Okay, so be careful. You always want to pick the largest. So square root of 16 is going to be 4. 5 is not a perfect square, so we keep it inside the radical sign. Okay, 44, that is not a perfect square. The largest is going to be 4. 4 times 11 gives us 44. Square root of 4 is 2. And then I have square root of 11, and that stays inside because we cannot simplify. Okay, 500. The largest perfect square is 100. Multiply that by 5. Okay, square root of 100 is 10. The 5 stays inside the radical sign. And that's our answer, okay? Notice that I'm taking the square root of the perfect square, and whatever is left underneath stays there, okay? And I only take the square root once. So notice like in number 6, when we took the square root of 16, I got 4. I didn't take the square root of 4 to get 2, okay? Only take the square root once. Make sure you write that down. Only take the square root once. Okay, 18, the largest is going to be 9. So we have the square root of 9 times the square root of 2. Square root of 9 is 3. And we keep the 2 underneath the square root sign because we can't simplify anymore. Okay, make sure you watch part 2 and part 3 of this video, which we will continue to simplify radicals.